Hi, today we're going to be learning a little bit about stoichiometry. For the given question, how many grams of magnesium nitrate are produced from 8 moles of nitric acid? The steps we're going to use to solve the problem. First, we're going to analyze the problem for its givens. 2, we're going to make sure the chemical equation is balanced. 3, we're going to need to find the molecular weights. And 4, we're going to set up the equation and solve. The last step is going to be making sure that the answer is in the correct number of sig figs. So what are the givens? First, we're given a chemical equation, and as we can look at the chemical equation, we can see that it is not balanced. Second, we're given 8 moles of nitric acid. So we're going to balance the chemical equation first. So we have the regular chemical equation written down, the one that they gave us, and we're going to start by writing down each element that is in the entire equation. So there's H, there's N, there's O, and there's Mg. Next, what we're going to do is we're going to count how many is on each side. So if we count the reaction side, we see that there are 3 hydrogens, 1 nitrogen, 5 oxygens, and 1 magnesium. If we look at the product side, we have 2 hydrogens, 2 nitrogens, 7 oxygens, and 1 magnesium. So what we're going to start with is the nitrogen. I usually use hydrogen at the end just because it usually balances out on its own. So if we look at the nitrogen, we see that there are 2 nitrogens on the product side and only 1 on the reactant side. So we're going to add a 2 in front of the nitric acid on the reactant side to get us 2 nitrogens. And then we're going to write out the rest, so that changed the hydrogens to 4, and it also changed the oxygen to 8, but it kept the magnesium at 1. So now what we're going to do is we're going to look at the oxygen. So on the product side, we only have 7 oxygens, and then we had 8 on the reactant side. So we're going to go ahead and add a 2 in front of the water just to make it 8 oxygens. This is also going to balance out the hydrogens and get us 4 on each side. So as we checked, we had the balanced equation now, so it's going to be 2 to 1 to 1 to 2. So now we're going to find the needed molecular weights. If we read the problem again, it says how many grams of magnesium nitrate. So we can stop right there, and we know that we need grams and we need it in magnesium nitrate. So what we're going to do is we're going to find how many the molecular weight grams per moles of magnesium nitrate. So we're first going to look at the magnesium, and that's going to be 24.305 grams per mole. This number can be found on the periodic table. Then we're going to do the same for nitrogen. We have 14.007 grams per mole, and then we have oxygen, 15.999 grams per moles. So the next thing we're going to do is we're going to find out how many of each we have. So for magnesium, we only have 1, so we're going to multiply the 24.305 by 1, and then we're going to get the same 24.305 grams per moles. Then for nitrogen, as we can see at the top from the equation of magnesium nitrate, we have 2 nitrogens. So we're going to multiply 2 by 14.007, and we're going to get the 28.014 grams per moles. We're going to do the same exact thing for oxygen, and we have 6 of them. So we're going to multiply 6 times the 15.999, and we're going to get 95.994 grams per moles. So what we're going to do to find the molecular weight of the entire compound is that we're going to add all of those together. And that's going to get us 148.313 grams per moles, and that's going to be of magnesium nitrate. So now we're going to set up the equation and then solve. So here's our balanced equation that we already solved for, and we're going to start by writing our given of 8 moles of nitric acid, and we're going to put that over 1. Next, we're going to look at the relationship between the moles of nitric acid and the moles of magnesium nitrate. So we see that on the reactant side, we have 2 moles of nitric acid, and that's going to yield us 1 mole of magnesium nitrate. Then we already know that we solved for the molecular weight of magnesium nitrate. So what we're going to do is we're going to put the 148.131, which is the grams of magnesium nitrate, and we're going to put that over 1 mole of magnesium nitrate. And that's because we know that grams per mole is what molecular weight is. So if we have moles of magnesium nitrate and we cancel it with the moles on the bottom of magnesium nitrate, we're left with only grams. So we can see that here by the cancellation. We're going to have the 8 moles of nitric acid, and that's going to cancel with the moles of nitric acid at the bottom. And then we're going to cancel the moles of magnesium nitrate with the moles of magnesium nitrate. And that's going to leave us with the grams of magnesium nitrate. So if we multiply across and then divide, we're ending up with 593.3 grams of magnesium nitrate. So given at the beginning we had 8 moles in the problem, they gave it to us in 8.00. This means that we have 3 sig figs. We're going to make sure that the answer is also in 3 sig figs, and we're going to know that we need to do that by using the sig fig rules for multiplication. So the final answer with using 3 sig figs would be 593 grams of magnesium nitrate.